today's tutorial is going to be on cross-sections perpendicular to the x-axis. So first is prior knowledge. So some prior knowledge. This problem is going to utilize calculus practices such as area between two curves, volume, and cross-sections perpendicular to the x-axis. To be able to attempt these problems, students will have to have knowledge of integrals and calculator functions such as Math 9 and graphing tools. There needs to be an understanding of geometry, including equations for area and volumes of shapes. So here's some common errors that people come into contact during these problems. When typing the equations into the calculators, they may miss parentheses or type it in wrong, and that is one of the major errors for giving the wrong answer. To avoid this, pull the constant value out in front of the integral to make the problem easier to solve. Reread the question and make sure that the question is asking about cross-section perpendicular to the x-axis and not the y-axis, for this will give you a completely different answer. So let's go over an example problem. Let R be the region enclosed by the graph f of x sine pi of x, and g of x equals x cubed minus 4x, where R is defined such that x is greater than or equal to 0 or less than or equal to 2. The region R models the surface of a small pond. At all points in the region R, the depth of the water is given by h of x equals 5 minus 2x. Find the volume of water in the pond. So I'm going to show you how to plug this into the calculator. So first you have to turn it on. Then y equals over here. So I already plugged these in. You plug in the two equations. It doesn't matter which order. And then we're going to press graph. Once you do that, you'll get a graph that looks somewhat like this. If it's not exactly like this, don't worry. It might just be because you have a different setting in the Windows area. So let's look at the Windows. So here are my Windows settings. Now in this problem, it says that the x will not be any less than 0 or greater than 2. So we're going to fix that so it will be easier to see the graph. So I changed my minimum to 0 and my maximum to 3 for the x-axis. So I'm going to press graph again. So you're going to get something like this. This is the R region right here. And if it doesn't give you a specific range on the x-axis, the way you're going to find that is through the intercepts. So we're going to do that. So we're going to do second and then calculate. And then we'll scroll down till we find intercept. And that is going to be number 5. So you can either press enter when you get to this, or you can just press 5. So then you pick first curve and second curve. It doesn't matter which order, so first curve, second curve, and then we're going to do guess. Guess means you're going to get as close to the point where they cross, and you're going to press enter. So it's at 2, 0. So that means that the section is enclosing the entire area. And so to make this graph a little bit easier to see, we have this. This is going to be the top curve line, and this is going to be the bottom curve. And that'll be helpful later on in this tutorial. So in the problem, it also says that the height of the pond is given by an equation, h of x equals 5 minus 2x. So when you use cross-sections, it'll create a volume that looks kind of like this. This is a front view, this is a side view. Kind of gives you an idea of what we're finding the area or the volume of. So now we're going to do the equation. So this is the normal equation. Basically, it is the surface area that you find times the height. So surface area most likely will be the top equation minus the bottom equation. So top equation minus the bottom equation times the height. So we are going to figure out which one's the top and which one's the bottom. So the top equation is going to be sine pi x, and the bottom equation is x cubed minus 4x. So now that we have that information, we can plug it into this section and then plug in the height. So we are going to do that. So this is the equation. This is the range on the x-axis. And then these are all the value things plugged in. And this will be the answer. So to get this, I'm going to move this to the side real fast. I'm going to press second quit to get out of this. And then I'm going to press the math key. And then I'm going to press, first I'm going to scroll down, but you can also just press 9. So you can scroll down with the arrows, or you can just press 9. So I'm going to press 9 because that's easier. Okay, now we're going to just plug it in exactly the way I showed you earlier. So it's going to be 0 on the bottom, press the arrow up, that's going to be a 2. Then I'm going to plug in the rest of the problem. Again, when I said at the beginning of this tutorial, please be careful of parentheses, because if you don't put one in, it can drastically change your answer. So I'm going to start a parentheses, and then I'm going to do sine pi x minus, I'm going to put another parentheses, x cubed minus 4x. I'm going to close the parentheses from that part and the other part at the very beginning of the sign, and then I'm going to press a parentheses again to do multiplication. I'm going to plug in the other equation, 5 minus 2x, and then I'm going to go over and do dx because it's perpendicular to the x-axis. I'm going to press enter. And look, we get the same answer. Of course, this one's rounded, but that one's not. But you can see it's the same answer. So that is all we have today. This is cross sections perpendicular to the x-axis. I hope this tutorial was helpful. And good luck with calculus.